So, I can have 500 into 100 milliamps maybe 0.5 watt. So, if I have 0.5 watt, that is enough to keep it the edge very much warm, and further if I want to heat it and all that, I need to work more on it, but this is the starting point. Now, having this, now we come to the other equally important thing, saying if you see my this 18650 cells, typically a 18650 cell has 65 mm height and then diameter is probably around 18 mm. So, I need to make a cell and see how well I can keep the cell here. So, I will try, I will have a what you call go at the cells here to see how good I am still at making this. I do not have the internet. So, this is 12 mm, this is 16 mm. Oh, let me take something arbitrarily. So, I have a, oh, it is looking ridiculously big. Let me assume, since I have not taken too much and then I will try to now extrude it and see what best of a what you call extrude a planar curve. See, this could be one of my cells. Now, I try my best to play around and arrange it, and then just for little embellishing, and which I require to identify the thing also, I need a small cap here. This cap makes this at least look like a full fledged cell. See there, I have a cell there. Now, it is for me to what you call play around as much as I would like, have as many cells I want. Do I make them stand, do I make them what you call flat, and what is a critical thing here? In this case, the student sort of took it saying the form is equally important, and what that groove is I am not able to right now, I am not able to judge. I expect it a stowage for the wire, and maybe he has given a way by which you can probably push something or keep a packet of sugar and tea bags. So, we have a place there for storing sugar and tea bags, and we have also a USB thing outside, that is actually an optional thing. So, he has made it in 2 rows. So, I can in fact take this here . I have 3 on one side, and probably there was a printed circuit board or something, and I now move all these things up to the other side and move this here flush. So, I have enough place here for a power supply and to make it symmetrical. I do not know what actually prompted that boy to make it like this. There may be, I am not able to at the minute tell you what it is. So, we have the starting point for our design here. Can you see? I have all the cells in place. Now, I need to build the remaining project, make a box all around it, and right now to go a little faster, I will remove the cells completely, meaning I will hide it. We will get back to it in due course when the time comes. We have come back to our cup. Now, I will try to go a little faster as I can. Now, from here onwards, this is the side view. If I see this side view, it is easy for me to make a solid. It is actually a box. It's the form is emerging slowly. If you see here now, it is for you to decide how you are going to deal with this situation. So, he has done a very convenient way saying, obviously all this is looking ugly, why can't I am sorry. Sorry. Why can't I just stick to this basic form? Okay, that is the basic form which seems to have made sense to him. Right now, I will delete this and then make something which is actually very aesthetic. That one looks way more aesthetic than what I can imagine. So, I make a solid here which is again a box, and see, I am getting that what he could do. The easy for me, easiest thing is I try to cut it and remove the inside surface and all that. So, this is the basic, and then removing, and on this box a lot of what you call trouble has been taken, and they he has sliced the box, he has made it open into two parts, there is a top portion and bottom portion, and then the taper itself is a challenge. And how do you build this? And the beauty is it was built and demonstrated. So, this is actually the part of the what you call the product as well as the this thing. Please show them the this thing, sir, this monitor. If you see the monitor, I can explain these things. Please show them this this PC laptop. So, I will see what best I can do here. See here. So, not impossible to make that nice thing here. Right now, to make things a little more simple, I will just do a simple what you call a Boolean difference and cut it off later. One piece is hidden, the other piece is used for the see there. I have a what I think is extremely clever object. I have something there which is cut, and something there which is there, and all that. If I want to, it is easy for me. All I need to do is make some arrangement by which this inside surface I can probably explode it and see one after the other. I will remove these surfaces. This is part of it which I could manage by making the Boolean operation. Now, when I unhide what has been hidden and remove all these cells, my project is almost ready. See, I have a nice formation of a cup like this, and you can see a little bit of the detail also at the bottom it is there. Then I have a box. Next is you need to decide how to print it. Luckily, in the case of our 3D printing, unlike our other thing, you just need to either print it straight away without the base or invert it. If you invert it, we end up with that peculiar overhang like this. So, in this case, this helps in building it straight away. Printing it like this in the same form is about the easiest thing to do. Now, inside the whole thing is a solid. Now, I go around and try to see how best I can make. I will make use of the all that surfaces which I have used earlier. How best to hollow out all the material inside. I can make something which sits comfortably, and if I turn it over, okay, you have seen this here. It is possible for me to make it into a solid. I take all this and join all these surfaces and make it into a solid. I join them. Since the whole thing has been joined, and I try to also use the solid command to create a kappa planar hole. I have what looks at least at the first level a beautiful object like this here. Now, it is relatively easy for me to use this bottom what you call, I have this bottom surface and try to cut through that material and try to remove as much of material as possible in this. But what makes a little problem for me is this cup like structure here. Now, I need to find out a way how to create that hollow surface in a possible way. This is where building at model becomes a little what do you call, a little tricky, as well as I mean that is how it is. Just to show you what can be done is, I will just try to now once again, as I have done before, I will try to remove the bottom surface. You see here, this is the object. See, it has come so far. Now, I need to do something to make sure that these surfaces, I convert these things into surfaces and attach them and join them. The moment I join them, I have something which can be printed easily, and chances are there will not be any what do you call surprises and problems, and you see here it looks reasonably good. Only thing is, now I need to worry about thickness here. You see here, this thickness has come here into this corner. Now, if I go off there, it will what do you call, it will intrude into this surface and create a problem for me. So, it is I use all my ingenuity to see what best I can do to prevent it, to see if there is a thickness, if there is enough material, what to do. So, I will now have a go at it, and just be patient with me. I make a solid out of this surface what I have here. Anything has happened? See, something else has happened. This is probably not what I wanted. Seen this, no? It is nice, it has gone off into the other direction, and it has extruded here, which I still have the old surface which is there. Now, I will try to go inside on the other direction. Am I better off? Maybe, maybe not. See here, not so much of a damage. It is not bad enough, at least I have come this far. It is easy for me to remove that material. Can you see here? I have something here which has extruded. That is easy for me. I can take this cone again, make another cone, and easily remove that material. But in principle, the outside sits flush. It is not as good as what my student managed, but I have got something here which is not bad. I will say not bad is all I can say. Now, I will try the same thing for all the other surfaces, see how well I am doing, and then get back to whole thing, and then try to again, now I extrude this surface straight. This is slightly better. The thickness did create a problem here, thickness is not so much of a problem. So, maybe I should do it there also. You understand? No? Maybe I should do it there. And incidentally, you have seen one more thing which I have managed. To prevent that thing from getting jammed, I may have small flutes all around. These flutes have an advantage to make sure that they do not jam the other thing. Disadvantage being it will prevent contact. So, not a very good idea to have these flutes. So, I need to now do something and trim them off. It is very easy to trim them off. I will show you later. And however, to me, this seems to be a much better option than this. So, I will remove this poly surface, use this surface again for see here, this is slightly better. Same thing I will do with this surface also. And with this surface, last surface which needs this splaying. And I have got these two bottom surfaces which I have left earlier. My project is almost ready now. See, I have a cup and it is hollow, and I have placed now to maybe put a printed circuit on the other side, and printing this is relatively easy. Now comes the important thing saying, but sir, we have a little problem, what do we do about this thing? Now, if you are to print like this, while we have solved the problem here no, large amount of support material is required. So, you need to make a trade-off, a trade-off saying, would you like to print it this way or would you like to print it upside down this way? If you print it this way, support material ends up in the cup, but this prints easily. Now, if you print it the other way, that also prints. So, is there any other way out? Obviously, there is a very simple way out. Why do we? There is no particular reason why this top surface should be built and it should look like this, is it not? So, instead I will remove the top surface and try to build it from the other side. See how? See this here, I build from the bottom surface instead, and this angle, I mean, being not too much of a problem, it is very easy for us to build from this surface, no problem at all. You understand, no? Or I can build it from here. So, either way the total amount of material that is required and how it is, I need to play around with it a little. So, generally this particular decision you can take once you load this onto the machine there, saying building it this way, will it make sense, or building it upside down, will it make sense, this being an inclined plane, no. So, where does the support material come? So, in my experience, it is probably easier if you build it upside down like this. You understand, no? So, that thing starts building, and one after the other is enough support material which is makes to build here. Alternatively, if that machine, no, it is more convenient for the machine to build things like this, we can build even this way. So, both the things are perfectly valid, and from purely from the what you call matter of convenience and aesthetics and all that, no, this is probably much easier if we allow it to build like this, because that angle is not less than 45 degrees, there is still a little slope. This is straight 90 or 0 degrees, this is full 45, this only about comes to maybe around 30 degrees off from the normal. So, if you go around and check, most likely it is easy to build without too much of a problem. And afterwards, like we have done before, we need to provide the various bosses and all that, and in this case he had made a place for a tea sachet, tea and milk sachet, and probably a spoon. Now, can we build the spoon also into this? Yes and no, depending on the type of plastic you use, probably no. It is much better to take a wooden or what do you call any throwaway spoon and then use it for stirring, or in the case of purists, they just put a tea bag, steep, maybe shake it with that, throw it away and take your cup out and start drinking with it. So, this is the story of my what you call that USB what do you call, I will call it teacup or whatever it is. So, there are various slides, various control is possible, how it sits, and then how do you attach, and then how do you build this product, what is the angle, and if it is not very deep, mine looked unnecessarily deep, it is very much possible for us to build this product. So, thank you. Next session I will probably show you something else, which is this. If you see this, I have, if you remember, I started with a light. So, next session talks about a relatively easy thing to build. In this case, it is built out of two shells, one shell on one side, one shell on one side, but the real life what we build does have a texture. This texture problem here, can you see? This texture does give a problem here. This is the CAD model, this is the 3D printed model. So, it is not impossible to finish it. What can always be done is, you can coat it with any of your what you call paint primers, or there is a plastic primers are there, and use good old manual skill to make it smooth. But the reality is this product is real, the one on the right side is real, the one on the left side is the what you call, our students have made a CAD model. So, automatically you will not get this model here, though now it is readily available. The what you call surface finish is still a problem, but colored materials and smoother materials are possible. And here more important, what the students have managed is, they have managed a LED bar graph. So, I will explain to you the product better. So, I will stop here, and maybe in the next session when I show you another sample, and maybe we will try to build it. So, thank you.